Hey, hello everyone. Welcome to the session. Hope you all are able to hear me. Can you please confirm on whether you are able to hear me or not?
Yeah, we can hear
I
you.
will, while you guys respond, I just wanted to open the Epic Pen, which will help me ensure that I write the details here. Can you all please once again confirm on whether you are able to hear me or not? First session, there will be glitches. Okay. And just ignore if there is any background noise. Just ignore that, friends. Okay, wonderful. So friends, let us get started. Hello everyone and welcome to this session on machine learning on cloud. And in the due course, there are two additional things that I'm going to talk about. One is auto ML, and I'm also going to talk about explainable AI. The beauty with auto ML is that you need not write even a single line of code. You need not have knowledge about any algorithms, and yet you would be implementing artificial intelligence. And this is the future, right? And you need not absolutely write even a single line of code. You need not have knowledge about even a single algorithm, and yet you can implement AI. And that is absolutely the future, friends. And the goal of artificial intelligence is to achieve AGI, artificial general intelligence, helping even the lay person understand artificial intelligence is going to be the future. Having said this, let me quickly introduce myself by opening my LinkedIn profile. Friends, so this is me. My name is Bharani Kumar Depuru. I am an Industrial Revolution 4.0 implementer, chief data scientist, and technology advisor on 4 different companies. I hold a master's degree from both Indian School of Business. Let me scroll down a bit. Okay, I hold a master's degree from Indian School of Business and IIT, Indian Institute of Technology. I work with companies such as HSBC. I work with ITC Infotech. I work with Infosys. And Deloitte was the last company with which I was employed as an employee. Post which, I'm doing a lot of things in the space of AI. And I'm working with a lot of additional companies to help them implement artificial intelligence. Okay, that's in short about my profile. And if you feel that it makes sense to probably get in touch with this guy called Bharani, yep, you can. And this is my LinkedIn profile. Okay, so feel free to connect with me. That's something that you might want to consider. I'm connected with a lot of head of HRs of various companies. If you feel that you can serve on my connections, feel free to do so. Back to our discussion here. Okay. So you have machine learning on cloud and auto ML, and we also have explainable AI. No programming, no algorithms, and yet you can implement AI, and that is exactly what we are going to learn as part of this. So friends, even before we get started, I frequently encounter this question, which is, what is the difference between artificial intelligence, data science, machine learning and deep learning? I frequently keep encountering this question. So we will first try to demystify this and try to understand what is artificial intelligence. Artificial intelligence is all about automating the human intelligence. What do you mean by human intelligence? Let me explain. If you're driving a car, what do? You control the steering. And what else do? You apply brakes. And then you change the gears. So on and so forth. All these things are performed manually by humans. But then, if you can automate this human intelligence, whatever a human is doing through human intelligence, if you can automate that, it is called as artificial intelligence. And now we have autonomous vehicles, SDCs, self-driving cars, driverless cars. All these are examples of artificial intelligence. So what do any self-driving car do? It will control the steering, it will apply the brakes, and it will, change the gears. And this part, which is manually performed by a human, is automated using some intelligence which is artificial in nature. And that is called as artificial intelligence. To achieve artificial intelligence, we use techniques such as data science. Okay, data science is, if I were to tell you, is a field where you analyze the data. For instance, if someone is doing some research in a field, in some field, in any field for that case, they're called as scientists. And someone who does research on data is called as a data scientist. And if the field that they work in is called as data science. Data science can be implemented using a lot of algorithms. And all these algorithms are part of something called as data mining. Data mining has a lot of fields, my dear friends. Supervised learning, unsupervised learning, and reinforcement learning, semi-supervised learning. Bunch of algorithms exist. But the goal of all of these algorithms is to analyze the data and mine the data. It is very similar to something called as coal mining. What do you do, friends, in coal mining? You dig coal. And when you keep digging coal, if you're lucky enough, you get access to diamonds. And diamonds are very precious. Precious than gold. When you do coal mining, you keep digging coal, but then you'd be extremely happy if you can get gold. Diamond. On similar lines, you keep digging the data, and if you get interesting insights from your data, similar to diamonds, If you dig coal, you get diamonds and you'll be very happy. Once a while, you get diamonds. On similar lines, when you dig data, when you analyze data, you get access to very interesting insights. And those are the insights which we should be really concerned about. And that field, which will help you extract the insights similar to diamonds, is called as data mining. Within data mining, you have a field which is called as machine learning. Machine learning supervised algorithms, machine learning unsupervised algorithms, etc. And machine learning will help you identify patterns in the data. Okay, patterns in the data are analyzed, are identified using machine learning algorithms. And within machine learning, you have a field which is called as deep learning. Right? Within this, you have a field called as deep learning. And deep learning is synonymous with a term which is called as neural networks. Neural networks is a term which is synonymous with deep learning. No matter what you do, no matter what techniques you apply, at the end of the day, you end up implementing AI algorithms. No matter what techniques you apply, at the end of the day, you end up building AI applications. And this is the difference between artificial intelligence, data science, machine learning, and deep learning. A lot of times people get confused on what is the difference among all these terms. And I'm hoping that now this understanding is clear. Next. This is very important, friends. You might feel, oh my God, these are all so trivial things. We already know about that. Right? Though you know, probably I would have added some more information to it, right? So keep accruing knowledge in that way. All right. And there are a lot of fields which have emerged of late. Right? You have fields such as data analyst, data engineer, data scientist, etc. What is the difference among all these fields? So say, whatever be the field, data engineering or data analytics or data science, you ideally deal with data, right? You deal with data, simple. You take the historical data and then you analyze the data. Historical data or past data, and then you analyze the data. If you take this historical data and then say this is your present, and on this side you have your past, and on this side you have your future. This is your present. You're taking the data until the present, and when you analyze the data, and when you make statements about what has happened in the past, what has happened in the past until now. For example, you know about COVID. It has changed the way we live, the way we do our businesses, etc. If you take all the bunch of COVID-19 cases of India, right, and then that's the past data, all the COVID-19 cases until now, that is the past data. And then if you talk about how many COVID-19 cases did we have until today? How many people have succumbed to COVID? How many people recovered from COVID? How many people are inoculated? How many people are vaccinated? And if you keep asking these kind of questions from the past, okay, and if you answer questions pertaining to past until now, that is called as data analytics. Data analytics. So you take the data, past data, and comment until now. That's called as data analytics. But then if you start thinking about the future, that is how many COVID-19 cases we might have in the next 6 months, in future, in the next 2 months or 3 months or 4 months or 5 months or 6 months, right, into the future. How many people will be inoculated, vaccinated, and how many people will take the booster shots in the next 1 year or 9 months or 6 months, whatever be it? Then you are talking about future, and that is the role of data scientist. Okay, it is data science. Data science is a field, and the person who performs data science is called as a data scientist. Data scientist performs data science activities. Okay, and a data analyst performs the role of data analytics. So on one side, you have data analyst. On another side, you have data scientist. Data scientist performs data science activities. Data analyst performs data analytics activities. All right. So data science is all about being proactive. Even before something goes wrong, you take an action. But data analytics is all about being reactive. Means only if something goes wrong, you take an action. Already something has happened, because you're only talking about present, until present. But the moment you talk about future, you become proactive. Means even before something happens, you take an action based on your predictions. Based on your predictions, you take informed decisions. So on one side, you have data analyst, on one side, you have data scientist. But then data scientist is a person who also need to understand what happened until the present. Only when you understand what happened until the present can you talk about the future. So data scientist also performs data analytics roles. Okay. All right. Then we also have a role which is called as data engineering. Who is a data engineer? Data engineer is a person who will ensure that the activities of a data analyst and a data scientist is performed seamlessly without any overheads. For example, you'll have data, right? To analyze or to perform data analytics or data scientist activities, you need access to data. That data will usually reside in database. Okay, you'll have a database and you'll have the data residing in that database. Whatever be the data, it could be a structured data set, or unstructured data set. Ultimately, you store it in database. Either you store it in SQL database or NoSQL database. It depends on what kind of data you have. Say you have data related to bank, right? Say you have data pertaining to a specific bank. And in this data, you have a lot of variables. And one of the variable, let me call it as Y, is whether a person will default on the loan or not. Okay, you have, say, access to 10,000 customers database. And in this, you have an output variable. This output variable is whether a person will default or not default. Say you have this kind of a data, output variable. Why is called as output variable? Just if someone is, they will become aware. So I'm just recapping for them. Certain things I have this habit of recapping, assuming that people who are attending do not know what this means, right? And then say you have a lot of inputs: age, income, gender, loan amount, loan category, every month installment, etc. And default means if you do not repay the installment for 3 months, 3 continuous months, according to the law of Indian government, you are considered as a defaulter. If you do not pay the installment for the loan that you have taken for continuous 3 months, then you'll be called as a defaulter. What do you do then? You take the data from the database into maybe something called as Python. To establish the connection between your database and Python, you need some API, application programming interface. API will help you establish the connections between 2 systems. It will help you establish the connection between the database and the programming language. There are a few commercial APIs which exist. There are a lot of open source APIs which exist, which will establish the connection between the database and your programming language. And then you do predictions. You build your prediction model, and that machine learning algorithm will classify whether a customer would default on the loan or not. And once you have your predictions ready, you might want to display your predictions on a web application or on a mobile application or maybe on some business application. Okay, you want to display the results on either the web application or mobile application or business application. And here also you need some connection. You want to connect your Python, the machine learning algorithm that you have built using Python. You want to establish the connection of that with one of these applications. There also you need an API, application programming interface, which connects or establishes the connection between 2 systems, 2 different applications. That's why it's called the application programming interface. It will interface 2 applications. Data engineer is a person who has to establish this entire pipeline. And data engineer is supposed to ensure that there are no errors when you put this particular architecture in production, meaning when the end users start using your services, using your machine learning application or machine learning algorithm, they should not encounter any issues. Seamlessly, if there is new data, you have 10,000 observations. If you have 10,000th observation, so on and so forth, all that new data has to automatically get processed, and the end result, the predictions, should get displayed onto your screen. Okay, that is how you build the model. Anyways, this is an overview of the different roles, or the three key roles rather: data analyst, data scientist, and data engineer. Okay, let's deep dive now. Reporting about past, that is the data analytics role, okay, is part of something called as business intelligence, BI, wherein you generate a lot of reports and dashboards. Okay, you generate a lot of reports and dashboards. But you're talking about past data, you take all the historical data and you talk until now, until present, what has happened is what you talk about. If you start predicting the future, that is machine learning usually, you predict the future. Then data science will help you create the new future. But is drawing the meaningful insights from your data and taking action on your data. If someone says, hey, there is 90% probability that the customer A who applied for the loan will default. If someone says so, then that's job of a data scientist. Finally, you have artificial intelligence, wherein you don't just look at this, you explore all the futures. For example, what if there is 80% probability? What if there is 95% probability? What if there is 99% probability? What will happen to the end result? What if analysis is something which is performed as part of your AI, wherein you explore all the futures. What if this customer A, whose age actually is 35 years, what if this person's age was 33 years? What if we give an interest amount of 8% instead of 10% to this customer A? What will happen? What if I reduce the interest rate to 6% from 8%? Will this customer A still default? We don't know, but we need to analyze. Given the historical data, we need to analyze. And that's your what if analysis, or exploring the future. All right. Now, AI for decision making. Artificial intelligence is used for decision making. To make better decisions, you use it. Usually, people do a broadcast. What does that mean? Say you have a bank. Say you have HSBC Bank. Okay, and say you have 20,000 customers. And you have a new offer. And that offer is, if you purchase new iPhone using HSBC credit card, if you purchase using HSBC credit card, say you get a special 5% discount. Broadcasting means you send this specific offer to all the 20,000 customers. Maybe you'll do some email marketing and send it to all the 20,000 customers of HSBC Bank. But what if one of those customers happens to be Sachin Tendulkar? What if one of the customer happens to be Roger Federer? What if one of the person happens to be US President Joe Biden? Would they be interested in 5% discount? And would that 5% discount email trigger these people to purchase iPhone? Not really. It won't help. So, and even worse, if someone doesn't feel that the emails that you're sending are going to help them, they will unsubscribe, meaning all the future emails that you send will not reach that customer. Or even worse, people might even select your email and click on spam. That is going to be even dangerous. So what should we do then? Right? Personalized decision making. Given all these 200,000 customers, perform something called as clustering or segmentation. And then you come up with a lot of segments. Maybe so out of these 20,000 customers, 5,000 customers belong to one cluster, maybe cluster 1. Maybe these are all affluent people, people belonging to some wealthy families and all that. Say you have another 5,000 customers, different segment. Say these are bridge customers. Who are bridge customers? Bridge customers are those customers who are almost buying the luxury products like iPhone. They're not buying yet, almost they are buying. They're buying products which are next to iPhone, just slightly less price than iPhone. To these customers, if you provide, say, additional discount of 5%, they might purchase iPhone. They might purchase iPhone. So probably out of all these different segments, you might want to send email or you want to do email marketing to these customers. You might want to do marketing for the bridge customers. So what happens here is you might assume that, okay, there is an offer of 5% discount. Let me send it to everyone. This is called as average, meaning on an average, a few people will purchase. Let me send it to everyone. How does it matter? Right? But I've told you that a few people might unsubscribe you, a few people might select your email and click on spam. You can get rid of all those issues by doing personalized or by taking personalized decisions. That's the beauty of artificial intelligence. So it will help you avoid death by average. Oops, sorry. I don't know why that popped up. Okay. Then instead of doing batch processing, you can do real-time processing, meaning you need not say that, let me have each and every customer apply for the loan. If all these customers are applying for the loan and they were applying loan to get some, maybe auto loan. Okay, so one way to deal with this is you take all the loan applications of A, B, C, and D, etc. And maybe A has applied for the loan at 10 a.m. in the morning. B has applied for the loan at 11 a.m. C has applied for the loan at maybe 2 p.m. and D has applied for the loan at 5 p.m. At different times, they've applied for the loan. Batch processing means I take all these loan applications where people are applying for the loan on a daily basis, and I'm going to process the loan at maybe 6 p.m. on a daily basis. So you're taking batch of all these loans, you're taking batch of all the loan applications, and you're processing that batch once at 6 p.m. And then you get the results on who are the various customers who might default on the loan. But what are you doing? You're doing batch processing. But what happens with respect to AI is that it will help you perform real-time processing. Means the moment person A applies, let me real-time process. B applies, let me real-time process. C, D. As and how they apply, immediately I'll process their loan applications. I'll pass it through my machine learning algorithm and give the result on that, on whether that person will default on the loan or not. This will help you avoid death by delay. You're not delaying anything. You're processing real time. Credit card transactions. Say customer A does a transaction at 10 a.m. Customer B does a transaction at 11 a.m. Customer C does a transaction at 2 p.m. and customer D does a transaction at 5 p.m. They're all using credit cards. If you say that I will do batch processing, what would happen? Even if there is a fraud, you will not be able to identify that fraud until 6 p.m. If it is batch processing. If you perform real-time processing, you can avoid death by delay. Then you have reactive versus proactive. Say you're manufacturing. You are into manufacturing. You are manufacturing, say, beverages. You know, if in any manufacturing plant, you'll have a lot of machines, right? If those machines fail, and then after the machines fail, if you're going to go and fix the issue, or if you're going to go and understand what went wrong after the issue happened, right? If you try to understand what went wrong, then you're being reactive. But if you take an action after something has gone wrong, okay, I mean, if you take an action after something has gone wrong, it's being reactive, right? But then what you can do is machines fail, machines break, right? It will cause disruption to your manufacturing, right? But then what you can do is, even before something fails or something breaks, you can proactively predict. You can predict when will a machine fail. That's called as preventive maintenance. All right. And this proactive decision making will help you avoid death by ignorance. You need not be ignorant about your machines on when will your machine fail, for what reason will it fail. All these things can be analyzed using artificial intelligence. And then you have tactical versus strategic decision making. Rather than talk about, okay, did you meet your sales or not for this day. Would you meet the sales for tomorrow or not? Rather than being just nearsighted, you can be farsighted, meaning what will be your sales for the next 6 months? What will be your sales for the next 1 year? You can actually analyze that and get into a strategic decision-making mode. And this will help you avoid death by nearsightedness. So these are the benefits of artificial intelligence. And here is the agenda, friends. Auto ML and machine learning on cloud, Amazon Web Services. We are going to talk about AWS machine learning services, Microsoft Azure, Google Cloud Platform, and explainable AI. When it comes to Auto ML, we will talk about theory and we'll also do practicals. And here we are going to resort to two things. One is we are going to make use of open source Auto ML framework, and we are also going to use licensed Auto ML framework. When it comes to open source, I am going to talk about Teapot, and I am going to talk about Keras. Okay, there's something called as Auto Keras, rather. Let me write the complete name here for your understanding. We will talk about both of these. When it comes to licensed, I'm going to talk about Amazon SageMaker, Autopilot. We are going to talk about Microsoft Azure ML Studio. And we are also going to talk about Google Cloud Platform. Once that is done, we will also talk about explainable AI. And for all of these, we would theoretically understand the concepts and practically we will solve it real time. So please pay attention on the theory as well. Theory is not to be taken for granted. We will also have the practical session. So one day it will be theory, on another day it will be practicals. Right? This is how we have structured it. Friends, whenever you deal with any data science project, you need to follow a specific framework to handle and solve your project end to end. And if you follow a framework, success rate of your projects will increase. And you have a framework called as CRISP-DM, which stands for Cross Industry Standard Process for Data Mining. And there is an enhanced version of this framework, which is called as CRISP MLQ, Cross Industry Standard Process for Machine Learning and Quality Assurance. Okay. Both these frameworks, be it CRISP-DM or CRISP-MLQ, both these frameworks have 6 phases. Okay, it has 6 phases. Business understanding. When it comes to CRISP-ML, you have business understanding, data preparation, modeling, evaluating your model, and deployment. These are the 6 phases of CRISP-DM. When it comes to CRISP-MLQ, there is a subtle difference. There's a small difference, and that is that these 2 phases, phase 1 and phase 2, are combined into a single phase. They are combined into a single phase. Then the second phase is data engineering. The third phase is modeling. The fourth phase is evaluation. The fifth phase is deployment. And the sixth phase is monitoring and maintenance. Monitoring and maintenance. This is the sixth phase. So your AutoML, a lot of your AutoML frameworks automate the entire framework. Okay, it automates almost, I should say, the entire framework. Not entire framework, but almost entire framework. And this is a very active field of research. People are working very, very extensively on this. Okay, so this is something which is given here. And it's an iterative process, etc. We are already aware of that. When it comes to AutoML, in any machine learning algorithm, especially when it comes to predictive models, there will be a lot of hyperparameters. For example, when it comes to decision tree, there is an algorithm in machine learning called as decision tree. There is an algorithm called as neural network, so on and so forth. In decision tree, you have a lot of options that you can change and experiment with. For example, number of trees. Number of trees that you want to draw, or number of iterations or trials that you want to run is something that you can experiment with. There'll be an option called as max depth. This is yet another hyperparameter. So you can keep giving different options for this, and you can keep experimenting, and you can see which option gives you the best result. So that's hyperparameter optimization. This has black box optimization, multi-fidelity optimization, etc. We'll not get into depth of that. And when it comes to neural network algorithm, you have number of epochs, number of iterations, batch size, learning rate, optimization algorithm, loss function, activation function, so on and so forth. There are a bunch of hyperparameters. Okay, and then what set of hyperparameters should you actually use to ensure that you get the best result is something which is not known to many people. Not many people are aware of this. Okay, and this is the place where you want some kind of AutoML to kick off, and you want your AutoML to try out all the various hyperparameters, experiment with all the hyperparameters, and then give you the best set of hyperparameters, which will give you the best result. Okay, then you have something called as NAS, Neural Architecture Search. What does NAS do? NAS will help you identify that these are the different architectures that can be experimented. For example, if you have structured data, or if you have structured data is also called as columnar data, or it's called as tabular data. If you have any of these data sets, then usually multi-layered perceptron architecture is used when it comes to neural networks. If you have images to deal with, usually it is convolution neural networks. And when you have textual data, it is usually recurrent neural networks and the variants of that. Depending on the data that you supply, your neural architecture search, NAS, would automatically figure out on what is the best algorithm or what is the best architecture which you need to use to solve your business problem. So the point that I'm trying to drive is, even if someone doesn't have the knowledge of all these things, such as if you have images as input, convolution neural network should be chosen. Even if you do not have the knowledge of that, your auto ML will automatically look at your images and figure out that convolution neural network is the right architecture. It will automatically identify, and that is auto ML. Then you have automated feature engineering. Friends, when it comes to machine learning algorithms, you have two branches. One is traditional machine learning algorithms. One is deep learning algorithms. One is traditional and one is deep learning. In traditional machine learning algorithms, you need to manually extract the features. Manually, you need to extract the features. That means if you have an image to deal with, you cannot supply the image as is to your machine learning algorithms. You need to extract the features. One set of features is pixel values. 1, 2, 3, 4, 5, 6, 7. 7 columns is what here. 1, 2, 3, 4, 5, 6, 7. 7 rows is what here. So you have images of size 7 by 7. That means you'll have 49 pixel values. And each pixel will have something called as pixel intensity. And each pixel intensity values range from 0 to 255. 0 means black. 255 means white. So you have pixel intensity values which range from 0 to 255. So what you do is you have 49 pixels, right? 7 columns and 7 rows. So you create a data set in that way. X1, X2, X3, X4, X5, X6, X7, etc. All these are pixel values. So if you have image 1, pixel value 1, 2, 3, 4, 5, 6, 7, in that way, you have all the pixel values. All the 49 pixel values. This is a manual way of extracting the features, which is time consuming. Traditional, when you have traditional machine learning algorithms, this is the only way to extract the features. However, when you have deep learning algorithms, you can automatically extract the features. This is one thing that you need to bear in mind. We have something called as reinforcement learning and evolutionary algorithms, EA. We'll talk about this also later. As part of TPOT, we'll talk about this. And we'll also talk about something called as genetic programming. Okay, anyways, all those things we will talk in theory, and also we will do practicals. Practicals is something that we will not do away with, right? We'll look at all that. And the beauty with TPOT is that it will basically perform, or it will come up with a lot of pipelines. Automatically, it will come up with a lot of pipelines, and then you can decide which pipeline is the best from machine learning standpoint. I'm talking only from machine learning standpoint. The pipeline that I'm talking about is related to machine learning. Okay. Anyways, so all these things we will also do practically. There is something called as feature tools, which is another library. We'll talk about this as well, and we'll see how this can automatically perform feature engineering. Okay. And you also have something called as meta learning, but I think we are time up. We would stop here. And tomorrow when we connect, we are going to take this discussion to the next level. We'll understand a lot of theory. And once we are done with the theory, we will get into the practical zone. Okay. All your questions that you have, you are free to post. Until now, based on the discussions that we have had, please post your questions, feel free. And then I'm going to look at your questions and address your questions in tomorrow's session. Thank you all so much, friends, for your patience. And sorry for the background noise, because I'm taking from office, which is very close to the road. From tomorrow onwards, affirmatively, you'll not experience any background noise. Yeah. Thank you so much, friends, and have a good night. When we connect tomorrow, we'll take this discussion to the next level. Thank you all. Bye.
One question. At what time the session starts daily?